Hey guys, this is Chemplified, and in this video we will talk about methods of preparation of chloroform. What is the general formula for chloroform? Molecular formula is CHCl3. This is the general molecular formula for chloroform. Let's start with the methods of preparation. Now the first method of preparation is when ethanol is treated with bleaching powder in presence of heat, you get chloroform. Direct reaction. Now second one is also a direct reaction. When acetone is treated with bleaching powder, you get chloroform, right? So these two are direct reaction. When ethanol and acetone are treated with bleaching powder, in both the cases you are going to get chloroform. Now since this is the methods of preparation, chloroform will be our final product. Now this is chloral hydrate, CCl3CHOH2O. This is our chloral hydrate. When this is heated in presence of NaOH base, we get chloroform. Fourth reaction, when carbon tetrachloride is heated or is allowed to pass through steam, right, in presence of iron, you get chloroform. Here iron is acting as a catalyst. It is providing the surface at which chloroform and steam come together to give chloroform. Sorry, carbon tetrachloride and steam come together to give chloroform, right? So iron is not taking part in the reaction, right? So again, carbon tetrachloride in presence of moist iron, we call it moist iron, you get chloroform, right? Now the fifth reaction, now this is an industrial method. Fifth reaction is an industrial method. When methane is treated with chlorine at 400 degrees centigrade, you get chloroform. So these are the 5 methods of preparation for chloroform. Now there is something else. I would like to discuss haloform reactions also. Generally it goes by the name iodoform reaction because iodine is used in many reactions, but the general name is haloform reaction. Now why we are discussing this? Because in all these reactions, in the final product you are going to get a haloform. In place of X, if you can write I3, since iodine is there, we call it iodoform, right? So first of all, let's see what is given in haloform reaction. I am reading this out. Aldehyde and ketones containing CH3CO group on treatment with excess of halogen in presence of alkali, that is base, produce a haloform, and that haloform could be chloroform, bromoform or iodoform. Fluorine is not there. In this reaction, all the 3 hydrogen atoms of methyl group are replaced by halogen atoms to form either trihaloaldehyde or trihaloketones, which react with alkali to form haloform and salt of carboxylic acid. So in this statement, first it is defined what are haloforms and which group is necessary for haloform reaction and what are the products, right? So the final products are haloform and carboxylic acid, salt of carboxylic acid. So let's discuss this reaction for aldehyde. The first statement is aldehyde and ketone containing CH3CO group. Now look at this aldehyde, acetaldehyde, our CH3CO group is there, right? This is our CH3CO group, right? And the carbon here is bonded with hydrogen. In place of hydrogen, some other carbon could be there, but we need CH3CO group at the terminal, right? So our first condition is satisfied. When it is treated with excess of halogen, we get trihaloacetaldehyde. All these hydrogens are replaced by halogen, right? When this trihaloacetaldehyde is treated with a base with hydrolysis, we get haloform and sodium salt of carboxylic acid. In simple terms, this whole group ONA will go to the carbon and this hydrogen will move to the second carbon or the carbon containing halogen atoms, right? So the final product is one of the haloforms and sodium salt of carboxylic acid, right? Now again take a look at the reaction is same, but this time the reactant is acetone. In the previous part we have acetaldehyde, this one is a ketone. Now again our first condition is the group should have CH3CO. So this is our group and this carbon is attached with carbon. In the previous case here hydrogen was there, now carbon is there. When this acetone is treated with excess of halogen, what you are going to get is trihaloacetone, right? All these three hydrogens are replaced by halogen atoms, right? And in the next step, when the same trihaloacetone is treated with NaOH and hydrolysis take place, then the final product is going to be a haloform and sodium salt of carboxylic acid. In this reaction also, this whole ONA group will be attached to this carbon, so you are going to get CH3COONA, and this hydrogen will go to this carbon, right? So this will give you a haloform or chloroform, bromoform or iodoform. So this was the haloform reaction, which it is an important reaction, so try to remember it, because you are going to come across this iodoform test. Iodoform test, right? And with this test include this complete reaction, right? So this will be it for today's video. I hope I am very much clear with the methods of preparation of chloroform. Thank you very much for watching.